Hello, everyone. All right, so I'm back after a little time off for the New Year's and drug into all kinds of other life things. So I'm back to work on the Kijimi and more, what do I want to say, main board troubleshooting. Where I left this was I'm not able to program the firmware. I can't remember the exact error, but it's something like Xcore 0, can't be found or not available or something like that. So Ando from the build group thought potentially it was the grounding on the main processor. Like it's not seeing the main processor is what it seems like to me. So he had me try adding some solder into, there's 4 holes on the back here. Maybe I can switch views to this one. Yeah, you can see in the center of the screen, in the middle of all the red circles, there are 4 kind of larger circular holes. And I put some solder paste in the top left and the bottom right one, and then used hot air to work that solder down in there, hopefully to make a ground plane connection on the back of the processor in the middle. That did no difference. And then I started testing the resistors, and as you can see in this picture, some of them read 60 to 70 ohms. Ando took a non-DIY build, but his production model, I guess, that is all SMD, what have you, and also measured the ohm readings, and they were the same. All the rest read open lead, no kind of connection. Just these circled ones read some amount of ohms. I said between 60 and 70, but it kind of varied in between there. So what happened from there? So I got connected to Bob at Black Corporation, and one of the engineers or technicians or what have you reached out to me yesterday and gave me a partial view of a schematic and some test point suggestions, which is what I hope to do today. I will say that in the meantime, here, let me switch back here. Before I do that stuff, in the meantime, I have been working a little off stream. I didn't stream all of these. I streamed doing the surface mount capacitors and the IC for the first voice card. And then I did all the the through-hole stuff as well for that first voice card, and that was it. I have since done the rest of the surface mount stuff for all the remaining voice cards. So if I can get this in focus, you can kind of see I've done the IC and all the capacitors. I did that for all the remaining 7 voice cards. So those are all complete now, which is great. It's just the through-hole stuff. Now, being ultra paranoid, what I did was starting really poring over the bill of materials, because on these voice cards, I originally ordered the SynthCube kit for the version 1 voice cards. Because I took such a long break in between, I never built those. I had problems with the first IC, so I stopped. And subsequently, I bought the version 2 voice cards. And what I did is I compared the bill of materials and basically tried to, port over any of the parts I could from the version 1 kit to the version 2 kits. That's fine. But what I did is I was just looking at values. Like if it was a 4.7, whatever, microfarad capacitor, that's what I looked on the first version 1 kit, and then I said, oh, I have one of those, done, right? Well, what I ended up doing is looking deeper than that, and I found, I don't know, maybe 3 to 5 parts that were slightly different. Meaning, one of the, maybe I'll pull these up later or on another stream or something, but one of the capacitors was, on the version 1 cards, was rated at 24 volts, and on the version 2 card, it was rated at 35. Same values, other stuff's the same, just the voltages were different, the ratings. I don't know how big of a deal that is, but in being paranoid about this now, I went ahead and tried to source any of the parts that had differences, and I think it was maybe three or four parts, something like that, mostly in capacitors. There was another difference in one of the other capacitors, I believe. I can't remember exactly what it was. It wasn't in the value or anything. It was just in how it was rated, I believe. Like, some of the detail, like I was looking at the, the spec sheets on Mauser and what have you. Okay, so I had to source some stuff, and the bad part is with this kind of shortage of components and all that stuff, it's really hard to source things now. Mauser, DigiKey, all these places are out of stock, and like some of their lead times are saying, oh, June of 2023, we look to have these back in stock. So that sucks. So I did manage to find one of the capacitors, which was the toughest one, and it was on Newark, but it was in the UK. So I ended up having to order through Newark and get it from the UK, and hopefully that one's on the way. DigiKey, I ordered, I think, 3 parts, and those are on the way as well. There was one part, I think Kemet, Kemet, that brand. There was some kind of film resistors. There's 2 of them on the main board. So what I'm also doing is, besides the voice cards, I'm also sourcing the parts again. I looked at all the main board parts, just in case I have to rebuild the main board. And like the one capacitor that's for the voice card is also on the main board. So I ordered, 5 or 10 extra or whatever, just in case this troubleshooting doesn't go well and I have to rebuild, say, the main board. Okay. So ordering a little parts, those are on the way. Some of them are, like I said, for the voice card. So what I plan to do is a couple of those capacitors. I built one full voice card. I will probably desolder, I don't know, I think it's 2 to 5 parts on there, and replace them with these capacitors that are exactly from the build materials. I just want to be super precise about that, just in case. What else? So where I'm moving on to today then is to try to troubleshoot the main board. What I've done is disconnected the hardware board, and I will go ahead and power up just the main board. And here, going back to this screen, my plan is to just so the email from the engineer at Black Corporation said first that I should measure the voltages on the capacitors that I showed in this picture, and see what the voltages are, right? So I think that's my first thing. What I'll do is try to, I have Photoshop open here, and I think what I'm going to do is try to write in the voltages for each one as I go here now, and just, note each of these voltages, see where they're at. And then he also said that I should check the clock signal on resistor 30, which took me a little time to figure out exactly where that was at. And I can pull this on the screen for you. I had some pictures from when I originally built this. And boy, I can't tell you, really, take pictures of all your naked boards because it comes in really, really helpful in situations like this, because a lot of these numbers get covered up when you solder. And it was actually tough for me because I didn't have a naked board shot of this, but I did have this one. And in the schematic that they sent me, which I can also show you in a second here, if I can pull it up here. I don't know if I have it anywhere. Anyway, they showed that it basically R30 is connected to the pin number 4 on IC28. So I was able to find IC28, which is here. It's on your screen now. I can zoom in even more. There we go. And so this is the dot. So this is 1, 2, 3, and this is pin 4. And I can see the trace running over here to this resistor. So I'm imagining that that is pin 30 because, you know, I think it is. I can tell that this is running the capacitor pin 2, pin 3, looks like it's running to this via or something. This looks correct. And then pin 5, I don't know, it looks like maybe that's a ground or something. It's a via going through the other side. Anyway, I believe this is resistor 30. And also in their schematic, they had the value. And I think this is like a 33 ohm resistor or something. So I looked up the resistor code and I believe this is correct. This is the right resistor. Okay. So this is my test. So why do I need that? I think I said, but I'm supposed to measure the clock signal there. I've never done this stuff. I've only used the oscilloscope a couple times. So this is very new to me. So this will be fun. So I believe what I have to do is hook up a test lead here, back to the oscilloscope, and then I should be able to see waveforms there and see if we're actually generating a clock signal from the main processor. So I think that will be a test we do as well. I don't know if we'll do that on cam yet today or not, but that's one. What else? Oh, I'm also supposed to read the reset pins. That's pin 2 and 4 of IC30. And I believe I found IC32. It is one of the ICs in the IC mounts that you mount in there. So that should be a little easier, I believe, as well to get kind of a test lead onto those and see. Now, with the reset signal, I know that's when you like power up the processor and things. It's in various states, and the reset signal kind of resets everything back to square to specific states. And what I think what it's either going to be is I don't know. Looking at this schematic, but usually those, or maybe I can see on here the reset signal. Hold on. I can't tell for here, but they're usually, I believe they're either high or low. So they're either in a high state, and when it resets, it goes low for a little bit, so many milliseconds, 50, 100, something like that. And then it would jump back up to high, or if it's in set to low, it stays low. And then when it resets, it jumps high for so many milliseconds and then jumps back low. So I think that's going to be another oscilloscope measurement where we hook it up and we wait to see some kind of state change when we power on. I'm not sure. I've never measured a reset signal, so that'll be something that we experiment with as well. But at least right now, I think what the goal is to go over and see if we can very carefully measure the voltages on our capacitors and see where they're at. I think that's the plan. Okay, so that said, let's go over, and I think what I'm going to try to do is if I go to like this composite view, there we go. I'm going to get rid of that. Okay, what I'm going to try to do is I'm going to try to test these, and then I think what I'll do is jump back and forth and try and maybe note on Photoshop what's going on. So maybe we can switch to, oh boy, we lost our iPhone SE. Let me see if I can reconnect. Oh, there we go. I think what we're going to do, like I said, is we're going to try to test each one of these and see, and then I'm going to note them here on the Photoshop. I don't think I can have this all on screen at the same time, but we'll go for it and see what happens. So I'm going to leave the mouse here, jump over to the other. I already have it connected to power and everything. I'm just going to power up just the main board on its own. The hardware board is in the back just because I have it all wired together, and the switch is still into the hardware board. But the hardware board isn't connected, obviously, because we're looking at kind of the inside of it. But what I'm going to do is go ahead and power up the main board, try to measure those resistors on that kind of top right side there, and then note some of the measurements. Okay, so we're going to go for this and see how it goes. I'm going to go ahead. I'm going to just leave both mics unmuted. Hopefully that works out well. Okay, so we're back over here. We're going to measure the voltages over here. So I'm going to set this to voltage DC. I'll stick this up here. I'll stick this on. And then what do we need to do? We need to power this guy up. So I'm going to go ahead. My power's here and there. That's plugged in. I'm going to go ahead and flip the switch here. Okay, I got all my power there. And now what we're going to do is just measure the voltage on this top right one. Hey, boy, I really don't want to like... I keep slipping. I don't want to like ground anything or like, you know. I can't read that display. It's just high enough up there where I can't read it properly. Okay, let's see. Okay, that's 1.018. So I'm going to go ahead and note these as I go here. So I'm going to be jumping back and forth. I guess I could switch over here. I don't know if I'm going to do this every time, but okay. And it's hard for me. They have the schematic, but because it's the reverse side of the board, I don't really know what's what yet. What's connected to what? It's really hard to tell. I don't know where these vias go through to the other side. I can try to trace that, but it's kind of tough right now. And I guess what I'll do is do the next one up to like here somewhere. Okay, so I'm going to go back to this view and see if we can do the next one. Down where I can read it again. .018 as well. Okay, maybe I'll do a couple of these. 1.018 as well. I think that was it too. 1.018. All the same there. Let's go to this bottom row. 3.303. 3.303. So the whole top row is 1.018. So that's kind of good here. I'll switch back to here. I guess what we can do is just draw a line indicating that these were all the same. So 1.018, and this was 3 point something. I'll draw down here. 3 point, and I want to just write it exactly. I think it was 3.3 something. Dude, again, I have terrible memory, obviously. It's extremely hard to see on this. 3.303. 3.303. 3.303 on all three of those bottom ones. 3.303. Which seems right. I mean, I know 1 volt, 3 volt, 3.3 volt. Okay, and all 3 of these were all 3.303. So now I'm going to do these 4 around this ring and see where those are at. So I'll switch back here, and we're going to do those 4 on the outside ring. Okay. This is tough. 1.018. 1.018. 1.018. Boy, there's like another component right above this one. I want to be careful. 1.012. Seems a little lower. 1.012. I don't think that's a big deal though. But I will note it. So I'm going to just draw a line again. Oh wait, we're on the wrong thing here. Oh no, it's the wrong. We're on the microscope. There. And draw a line up to here. 2, 3. Okay, those are all 1.018, and this was 1.012. Okay, there we go. And then we're going to measure, I guess, these bottom 3 and see where they're at. Oh. 1.018, 1.017, close. Kind of fluctuating. 1.017, 1.017. All 3 of those are 1.017. And then there are these 4 on the side that I guess I'll try. 1.018. Oh. 1.017. 1.017. 1.017. Just redoing them just to make sure. 1.017. So all 4 of those are 0.017. Can't remember what these were now. I think these were the same. Yeah, all 1.017 on that side. So all 3 bottom ones and all 4 top ones, 1.017. Okay, here we go. So these were 1.017 volts. You know, from here to here. Same for these. 1.017 volts. And that was 1, 2, and 3. There. Volts. Okay, so we got those recorded. Now, what was the next thing to do in there? I believe it was the resets and the clock signal on resistor 30. Okay, I'm sorry, this is my email. Okay, so R30 Now, I guess what I'm going to do is power some of these down. Maybe I'll, just for completeness, maybe I'll measure the voltages on some of these other capacitors around. Here, so let's go back to here. And then maybe what I'll do is just measure some of the capacitors that I didn't measure. Like, let's do these bottom three. Okay, this isn't on. That would help. Okay, this is 3.3 volts. 3.303. And 3.303. These are all 3.303. What other ones? These bottom four. Imagine this is all the 3 volt stuff. 3.304. 3.304. 3.304. Hi. 3.304. Okay, so those are all 3.304. Let's just do these two. 3.303 and 3.303. What were these again? 303 or 304? 303. I think these ones were 304s. 304. So those are 304s. Everything else is a 303. So these are the same. So here, I'll come back to this view. Okay, so these are also 3.303. All of these 3.303. And these are 3.304, believe. And that's this one, this one, this one, and that one. Okay, so we've measured all those. Maybe I'll just go ahead and do these upper two capacitors as well, just to make sure we got them all. 3.304 up there, and 3.304. Okay. 3.304. Okay, so all the other capacitors that were on the screen, these were all 3.304s. So 3.304 volt. Boom and boom, and also 3.304. Okay, so I just kind of did all of those. I can go ahead and save this file out. File, save as on my computer on the desktop, and we're just gonna call this main board capacitor voltages. I'll just do Kijimi. Kijimi mainboard capacitor voltages. Okay, there. I want to make that super high. There we go. So that part's done. Okay, so what do we figure out? So that part to me looks good then. It looks like all our capacitors are at acceptable voltages. Nothing seems weird there to me, unless the 1 voltage is off, but I could have swore I saw on the spec sheet some of those should be at 1 voltage, or 1 volt. Okay, so now what? We are going to try to do the clock signal. That's what we should do. R30, and we're going to try to do the clock signal on R30. And I believe that's just going to be one test probe on that resistor leg, and then try to see if we can get that to read out on the oscilloscope. So let's go ahead with that. What do I need to do here? I need to switch back. So I'm going to go to here. First, what I'll do is I'll switch over to, can I go to cam 2 there? There, we're going to go to that one. I am going to power this down now. Take the voltage off. Okay, there we go. And now, because I think we're working on the other side. So let me pull this over. And I'm going to flip this over. I think we're working on this side now. And can I see? Here, let me get this book out of here. I was using that to kind of prop that up so it was easier to test probe. Okay, where's my magnifier? It's kind of scary how much I'm going blind now. I'm going to need glasses sometime. So, okay. Can I do this? I'm just trying to do this really nicely. Maybe I can see it quite well on my side, but I want you to see it. Maybe I can pull this over. Ooh, and we could do this with the microscope. Not sure. It'd be kind of nice. Okay, I'm at my max distance here. Everything's kind of a nightmare to try to get things where they need to be for streaming. I can't tell you how much longer all this takes doing it streaming. It's really tough. Okay, so on my screen that looks awesome. And here's my test probe. I'm gonna pull this out, everything's all tangled. Take this grounder off. Get everything out of there. Okay, pull my test probe around. I'm gonna turn my oscilloscope on. I don't even know if this thing's plugged in. I haven't used it in ages. Let's see. Where is the power on this thing? I don't even know. There it is. Yeah, it came on. Great. So maybe I can get, just like that. Okay, so that all looks good. Power, nothing's like touching anything there. My probes aren't touching anything. Okay, good. Let's see if we can get the microscope view up. Okay, there's the microscope. That's the composite. That's okay. Let's see, can we get the right thing? On my screen, it's all in. Oh, there it is. Now it's coming in on your screen. There. And then maybe I can get a little closer then. So it's a little better for you guys. Boy. This is tough. Okay, yeah, that's all in though. And now let's try to get your focus, right? Okay, there. That's looks quite good from this side of the room. Okay, so R30. So IC28. Let me make sure I'm doing this right again. Let me look at the schematic here. Hold on, I have to minimize this thing. Pull this thing. Oh, it won't let me do it on Windows. Oh boy. I wish I here, hold on. Can I save picture as I'm going to do it to the desktop and call it Kijimi schematic. Okay, bear with me here. I'm trying to pull up the Kijimi schematic that Bob sent. Okay, so let's open this. Okay, now we got something. Now I'm gonna put this in the middle of the screen. Pull that back up. Leave that down for now. Okay, so here, and then I'll zoom in on this. So here, let me pull this up now. Here we go. It's that one? No, we want this one. Okay, so this is the schematic they sent. And I'm supposed to measure the clock signal on R30. And coming back to this microscope view, on the schematic, let me come back there. On the schematic, R30, which is up here. Can I zoom in? Yeah, there we go. R30 is connected to IC28. They have A and B. I think it's the same IC. They're just saying A and B because they're breaking out the pins. So for the schematic. So R30 is this guy. And I do see that it runs over to clock signal off the main processor. So R30 is here. And so if I go back now to the microscope composite, there we go. This is 28, and this is 1, 2, 3, 4, pin 4, and it's clearly running over to R30. So this is R30. So I'm going to put my test lead right here, and then run that, and then see if we get a clock signal when we power up. See what we get. So I'm going to go back to which cam should I be on? Is it this one? Or maybe the iPhone will be better. I think that one's going to be a little better. Unfortunately, well, maybe if I adjust this cam, you'll be able to see the oscilloscope as well. You can kind of see it there in the background. You can see it. So I'm not sure where to focus. Maybe I'll focus there because that's where it's bright. Okay, so the oscilloscope's in the background there, and you should be able to see the screen. And let me move this way. Okay, there we go. Trying to get things out of the way here so it's a little more visible. Okay, nothing's grounding there or anything. Yeah, so the oscilloscope's in the screen and our circuit board's there. So I'm going to go ahead. Now, again, I have this all powered off. I'm going to go ahead and just hook up this thing. Here, maybe I'll pull the mouse over here so we can switch views. Get that out of the way. And we'll go back to maybe the microscope view here. Yeah. Because what I'm going to do is go ahead and hook up this test lead to R30 if I can get it on there. Yeah, there's R30. Okay, there. So I have that guy hooked up. Hopefully that's making contact. Hard to tell. If it's not, I can kind of jiggle that around. But that looks like, just looking at it right now through here, that looks like it's making contact to me. Okay, so there we go. We're hooked up to R30, and it's reading something on the oscilloscope right now. But let me pull this back to where is our iPhone SE? There we go. So I see something on the screen there. Like I said, I've only used this a handful of times. So I'm not really sure what we're going for here. Now, can I disable channel 2? Because we're not even using that. So I turned off channel 2. We're only looking at channel 1. I'm going to just try to run an auto. I know you can set like the trigger and all that stuff, but my goal is to power this up and see if we get anything that way. Now, I am getting something on there now. I'm not sure what that is. Here, I'm going to hit auto and see what we get from that. Okay, so it looks like we're getting some kind of signal right now. I definitely see something there. Which seems kind of strange since we don't have any power applied to this board. But I don't know. Okay, so I guess what we're going to do next is run power to it. And I guess what I'll do is I'll run the auto there again and see if we can see what we get. Boy, it's hard for me to read all this. It seems like it's at 60 hertz or something right now. I guess that's power fluctuation? I don't know. Okay, at any rate, let's go ahead and power up this board and we can test this out and see where we're at. Now the question is, I don't think I need to ground this, or do I? I'm wondering if I could ground to that ground plate over there. All right, it's time for a quick Google. Hold on 1 second. I want to make sure I'm doing this right. I believe I can run it without grounding the test probe, but I thought you're kind of supposed to always ground the test probe. I can't remember. It's been ages since I've used an oscilloscope. So, it's time for a little Googling. YouTube. Okay, here's one. I can't hear this. I'm gonna have to throw on headphones here. Do we have volume? I don't hear it on your end as well. I'm not sure what I am missing here. Desktop audio? No. They are clearly not using a ground, I don't think, and just testing straight as well. So I think I'm going to be okay doing that. Sorry, you can't see this, can you? Yeah, so I'm looking at this YouTube video, and they had it like this. They were just had one probe, and then they are going over to the oscilloscope and starting to dial it in manually to set the frequencies and such. Okay, so I think I'm okay there, but how to use an oscilloscope testing frequency of crystals. Let's go to this one and just quickly see what they have in here. Okay, so they are using the grounds, and they're running a ground. Oh no, they're powering it through that, but they are grounding it. Maybe it would be a smart idea just to ground it to, I'm not sure, like a good ground point on there that I can attach to. Because I have some, I just have an alligator clip, and it looks like the posts on the voice cards are probably grounded, but it's hard to tell. I can't tell exactly, but it looks like they would be grounded. So maybe I could do that as a fail-safe. I don't know. I don't know if I need to or not. Let's see a couple others here. Let's see what they do on this heavy-duty board. This looks like some kind of logic board off a laptop or something. Let's go ahead and skip ahead, see what they're doing here. Okay, so it's obviously some kind of processor. Okay, I'm just skipping ahead to where they're testing the, okay, there's voltage. Okay, keep going. Okay, here's an oscilloscope. Now, how are they testing? It looks like they're only... Okay, I see their test, and they go out to a resistor as well. Clock. And it's hard for me to tell, but in his reflection, I'm only seeing one probe. And I don't clearly see a ground on there. I mean, it's hard for me to tell, but because it's just through a reflection, hopefully they will show what's happening there. No, of course they don't. So I'm not sure about that. I think they're not. I'm going to go ahead and try it without to begin with. Okay, what do we want to go back to? We want to go back to the microscope view, right? Oh, you guys, you look like you're a little out of the scene here. Here, can I pull this back in? Okay, there. So there's my test probe. Looks good on my end. Looks like it's making contact. Let's go ahead and give this power. See what we get. Make sure I'm not touching anything anywhere. We still have our test probe in. Okay, so I gave the main board power, and now let's just do an auto on our board here. I'm going to switch back over to the iPhone SE2. There we go. We got something on there now. What do we got? It says 50 hertz. Now it's like 60 hertz again. That looks strange to me, though. That does not look proper. I don't know, maybe I should be grounding this thing. I can also try it that way as well. Or maybe I have it out of... But I mean, it's obviously showing the waveform. But it doesn't look right to me. Really strange. Okay. So I'm going to power it off. See, what's happening when I power it off, it still has the same waveform, which is weird. Maybe I need to ground this thing? I don't know. I don't think so, though. Try that, too. And ground it to the... I'm grounding to the leg of the voice card. No, same result. What was the other thing they said I should try? So I'm not sure what I was getting there, really. You know what I'll do is... I'm going to take this off. Hook this guy up again. Power that up again. I'm gonna, oh shoot, I don't have a camera, do I? Okay, hold on a second, I need a camera. Be right back. All right, I'm just gonna snap a picture of that and power apply, do an auto. Okay, there we go. That looks super funky to me. What can we adjust here? Well, that's just adjusting up and down. Okay, that's not doing much. Yeah, that does not look right. Okay, so something's definitely not right there. I can just tell. Maybe I'm wrong. I don't know what I'm really looking for, but that does not look right to me. All right. So there we go with that. Just want to snap a photo. Now, what else was I supposed to look at here? I am also supposed to probe and look for, what was it? The resets on pins 2 and 4 of IC30. And I did figure that out. Reset signals pins 2 and 4 of IC30. And I believe IC30, well, I can't see this one with the glare. It's this one, the 4050. I don't think you guys can't see this on your screen. Here, I'll switch over. Looking through the microscope. This one. It's the 4050 chip. If I look at their schematic, here, let me pull this up. This is it. Here, let me go back to this view. This one. So they say on IC30 they have a 30A and B here. And they say it's the CD4050 IC. That's how I know. And they want me to check the, the reset, which is connected to pins 2 and over here to pin 4. Pin 2 and 4 is connected to reset on the 4050. And if I go back to the microscope composite, it's really hard for you to tell maybe. It looks dark on the screen to me, but that is the 4050 IC. Okay, so pin 2 and 4, if this is the top, it should be 2 and 4, I believe. This is pin 2, this is pin 4. It should count that way, I believe. Count around. Yeah, so pin 2 and 4, make sure our power's off. It is. Can I get that in? Maybe I can just do this. I really don't want to try to go in there on it. I think I'm going to have to just do this and hold it. Okay, we're getting something on the oscilloscope when I do that. Okay, so that's pin 2 for sure. So I guess what I want to do now is power this up and see if we get fluctuation. Well, that looks weird too, man. It just seems like... and I guess you guys can't see that. Hold on. You're in the microscope. Let's go to the SE2. So this is it powered up. And be very careful here. Stick this probe back in here. It's pin 2. On the monitor, you can see it. And it's basically like you can see stuff cycling in the main waveform. Which seems weird. Now let's just do pin 4. Same thing. Let's just read another pin, pin 3. See, it's doing the same exact stuff. Something that doesn't seem right to me. And there was no difference powering on or off. It was kind of, it's just that same wave, and then you see the fluctuations in between the smaller bands that are riding in that wave. So not sure what's going on there. So I may be using the oscilloscope wrong. Not sure. So I'll have to check with Bob on that one. But so that's my quick test of that. Maybe I have to revisit how I'm doing the oscilloscope. But that seemed very strange to me and not quite right. Okay, so where do we go from here? Let me pull this back here. I think we'll pull back to here. Hi. So, it's hard for me to know if I don't know much about the oscilloscope. I don't know if I'm doing this right, but that test probe, it didn't seem, I mean, I was getting like a deformed waveform, and then, you know, when I would power it on, I would get smaller, you know, bands, you know, blocks of frequencies that would ride on that main waveform. I was expecting to just get, you know, kind of a sine wave in a certain frequency to be able to test whether the main, you know, clock or whatever was, you know, coming out at a certain megahertz range or hertz or whatever, and just see a clean sine wave. It seemed like a deformed wave, and then when you would power it up, it would be like dirty bands with riding in that wave, like a wave within a wave or something. So I don't know what that indicates. It could be I'm not probing right as well. But so I think what I'm going to do is leave it here and touch back with Black Corporation, let them know where I'm at there. Maybe I'm probing this wrong, but we'll see. Maybe I'll post on the build forum as well. See how it goes. So I think I'm going to leave it here for today. Check with Black Corporation, maybe the build forum, and then go from there. Again, for the voice card side of things, I'm waiting for some more components to come in the mail, and then I will probably stream. I have 6 cards that will fit on my soldering station, the red thing over there. So I think when I get the exact bill of materials, I'm waiting for like 3 or 4 items. I'm going to go ahead and assemble all 6 of those at once. That will leave me 1 board left to do completely, and then my first board that I did, I'll have to desolder, I don't know, 3 to 5 items and replace them, mostly capacitors, I think, and replace those with the exact ones off the BOM. And then that would finish the voice card side of things, I believe. I am, fingers crossed, gonna, you know, figure out whatever's happening on this main board and, you know, get this resolved so I can get some firmware on there. So I'm gonna leave it here for today though, and I'll be back, get some more information, and continue either building voice cards, and then obviously whenever I can, I'll be also troubleshooting the main board and documenting some of that as well. Okay, so I hope you all have a good day out there. Stay well wherever you're at, and see you next time. So long.